6.5 is properties of logarithms, okay? So we have a nice little list here. We're learning more about logarithms. And what we learn in this lesson of how we can move logs around and stuff helps us later on when we're trying to solve equations, okay? So 3 log properties here. Now notice it says for positive numbers b, m, and n, with b not equaling 0, the following properties hold. So realizing positive numbers, b is the base, has to be positive, can't equal 1. M and n are numbers inside of the log, and they have to be positive. We've talked already that the base can't be negative, the inside of the log can't be negative. Okay, property 1, the product property of logs. It says if there is multiplication inside of a log, it can be you can take that 1 log and split it into 2 logs being added. So when you see multiplication inside the log, it can split up into 2 logs being added. For instance, log base 3 of 5x. Well, 5x is 5 times x, yes? So that can be rewritten as log base 3 of 5 plus log base 3 of x. That's your product property. Now, if there's a product property, guess what? There's also going to be a quotient property. The quotient property says if there is division inside of a log, there's division inside of a log and can be rewritten as 2 logs being what? Subtracted. Okay, so it works a lot like the product property. So for example, log base 2 of 7 divided by 3 is log base 2 of 7 minus log base 2 of 3. And then we have one more, and this is the power property of logs. This says if there is a power, such as the n, that power can be moved out front as a coefficient. So log base b of m to the n can be written as n times log base b of m. So log base 5 of x to the 4th can be rewritten as 4 log base 5 of x, because that 4 can move out front. Okay? So what we're doing on the front of this page of notes today is just learning how these properties work. Okay? Basically, we're going to do some rewriting. Okay? In Savas, you're going to be retyping these. In the top section, you'll notice it says use the properties of logarithms to expand each expression. So in the top examples, we're going to take 1 log and we're going to expand it into multiple logs. Okay? And then we're going to do the reverse at the bottom. So our job here is to expand. So log base 5 of a to the 2nd, b to the 7th. What do you see going on there within the log? There's multiplication, yes? There is a squared times b to the 7th, which means I can take this single log and rewrite it as 2 logs being what? Added. Because it's multiplication, this falls into the product property. Multiplication within a log is 2 logs being added. So I'm going to rewrite this as log base 5 of a squared plus log base 5 of b to the 7th. Now, for this fully to be expanded, there's one more property we need to take care of. What's the other property from above we can use?
The power property.
The power property. A power of 2 on the A can go where? It can go out front. In the same manner,
7.
the 7 can go out front as well. And so we're going to end up with 2
log base 5 plus 7 log base 5.
Except you're forgetting the A and the B.
Oh, shoot.
Okay, so move the 2 out front, and it's 2 log base 5 of A, plus move the 7 out front, and it's 7 log base 5 of B. Anytime they ask you to expand, They don't want any multiplication or division left inside the logs, and they don't want any powers left inside the logs. And that's your final answer. Questions?
It's easy.
It's not too bad.
It's easy.
Okay. Now, remembering how to do it all later when you don't have your notes in front of you, okay, that's a little tougher as we, try to remember how the rules work. But, okay, let's look at B. Natural log of 25/3. Well, do my rules still apply here? It's still a log, isn't it? Okay, it's a natural log instead of log-based something, but it's a natural log. It still applies. So what do you see happening here? Inside the log, we see
25 and 3.
and 25 and 3 are being divided, yes. Division within a log can be rewritten as 2 logs being subtracted. So I'm going to rewrite this as natural log of 25 minus natural log of 3. Now, what if I say we're not done here?
25 is a square
Hmm.
root.
So that gold paper might help you here. Okay, they're going to expect you to go one step farther. We know 25 is 5 squared, correct? So we just took 25 and rewrote it with a power. Well, we don't want powers on our final answer. So natural log of 5 squared, what can I do?
You can take 2 out front.
Yeah, that 2 can go out front. And so now I have 2 natural log of 5 minus natural log of 3. Okay? So just beware. If you see a number that possibly has powers in it, you need to try and catch that and rewrite it as such.
Wait, so like 25, you just like. Wait, so what if it was 16? Like ln 16 minus ln 3, it would be like 2 ln 4?
That would be one option. 16 is also 2 to the 4th. So there'd be multiple options to talk about there.
Okay, then what if it was 9? So it'd be like 2.
Anytime you see a number that has powers involved.
So it'd be 2 ln 3. Okay.
Okay, so just look for it.
I thought it was like, you brought like the whole number forward.
No, just the power. Okay, C. Log base 7 of r cubed t to the 4th all over v. What stands out most? Okay. In terms of debating what you mean by that.
There's 2, like, it's more complicated.
Okay. And I get the idea you're hinting at there's powers. But we're not going to worry about powers till the end. Okay? If I were to break this up just one way right now, what I see, you guys see division? That's going to be your easiest start. I'm not saying you have to start, but it's going to be the easiest start. So what do we know? If there's division, we can rewrite it as logs being subtracted. So I'm going to write this as log base 7 of r to the 3rd t to the 4th, and I'm going to put parentheses in there, minus log base 7 of v. Now, you'll notice I put parentheses around the r to the 3rd t to the 4th. I will say Savas was not making me put parentheses around things. So I'm not saying you'd have to. It's just good form, just want you to be familiar with it. Now, we're not done. We saw division. What else do we see? Okay, is there still multiplication in here? Yeah, there is. So we already separated the division. Now we've got to separate the multiplication. Multiplication within a log can be rewritten as 2 logs being what? added. So we're going to have log base 7 of r to the third plus log base 7 of t to the fourth. And don't forget, what do we still have?
Log base 7 v.
Log base 7 of v. Am I done now?
Now, yeah, powers.
Okay, folks, we've already used the other two properties. We've only got one property left, yes? We used our quotient property, we used our product property, and now we can use the power. We have a power of 3 and a power of 4. Technically on the v there's a power of 1, but we don't need to worry about that. So we end up with 3 log base 7 of r plus 4 log base 7 of t minus log base 7 of v. Notice every step of the way I have my base v or base 7 in there, don't I? Okay. Now do I have it all just plain basic logs, added and subtracted, multiplied? Okay, you want to get it so there's no multiplying, dividing, or powers left within your logs.
I can see how this could become a very, very tedious.
It can be. Okay, we ready for D? Natural log of 7x over 225. I always say start with the obvious. What's the obvious here?
The division.
There's a big old division sign, yes? Well, a fraction bar, but fraction bars, division signs, they overlap. So, if we're going to use the quotient property, we're going to say what? Natural log of 7x, and then what? Minus natural log of 225. Division within a log is 2 logs being subtracted. Now what?
Oh shoot, the 225. You do like that's like hold on, that's like 15, or it's a number squared, or like to the third. I mean to the third. You know what I'm saying? Like cube, like
I liked your first statement better.
oh squared.
Mhm.
It's 15 squared.
It's 15 squared.
Mhm.
Oh shoot! No, why didn't you just stop me? You just like looked at me. Whenever I said it's 15 squared, you were just like,
It was kind of fun
Look at
listening
that.
to you go on, kind of trying to figure it out. Okay, so now, and there's several different ways we could go with this, but 225, you're not going to find it on the gold paper, sorry. Now, the blue paper, we had square roots on there, didn't we? And 225 is listed in your perfect squares, if that helps. But 225 is indeed 15 squared. Okay. So I agree, we could rewrite that as 15 squared. And which means what do we have to do to finish that part out?
burn the two ahead.
Bring the 2 out front.
Yep.
There's something else I need.
Square the 7 and x.
Okay.
What?
7 and x are being what?
Multiplied.
Multiplied. It's not a power. They're being multiplied. Multiplication within a log can be rewritten as 2 logs being added. So I'm going to rewrite this as natural log of 7 plus natural log of x minus
2 natural logs of 15.
2 natural log of 15.
Wait, isn't it just ln? I was in natural log. What does that even mean?
Well, base e is the natural number, so it's natural log. Why it's natural log and ln is the abbreviation, not a clue. Other than a log should start with L, so it's log of the natural variety maybe.
What is like log even for? What are we solving? What is this for?
These properties right now are going to help us when we solve equations in the next lesson is what it's going to be. Okay?
Like what did those equations like solve? Is it like measurements or is it like
Wait, did you ever figure out what like the purpose of log is? Because pi, we talked about how
pi is circles, but then log is what?
Oh, no, that was the number E we talked about.
Oh, yeah.
Never mind.
And E is the natural number, and it's for the base log. I don't know that I ever found, like, pi is the ratio between the circumference and the diameter of the circle. I don't know that I ever looked up what E was, if E has some
You mean
ratio there or whatever. So, okay, guys, we've expanded.
we got 10 minutes.
We got 10 minutes to
You have 5 problems.
condense is the word I like to use. Okay, someone used the word shrink this morning, and I like that. But now here's the deal. We got multiple logs that we're going to take, and we're going to condense. We're going to shrink. Basically, we're going to reverse our steps from prior, right? Okay, so we're going to, whether you want to say condense or shrink, we're going to do the opposite of what we did up above. Can we do it?
Mm-hmm.
Okay, so where do you think we start an A?
Log 4. Log 4.
What do you mean?
Log 4 is like this thing that they all have the same as. So
Okay, it's log base 4. Oh, okay.
You know what I'm saying?
Okay, so you're saying my final answer is going to be log base 4 something.
Yeah.
Okay.
Take all of the numbers in the front and move them to the exponents.
Okay. And that's where I was looking at, I kind of want to take this in steps. You're just jumping to the final answer.
Yeah.
I'm not quite there yet. So let's start with, the last thing we did on the problems up above was the power property. So what's the first thing I'm going to do here? The power property. So the 4 can move up and the 3 can move up. So I'm going to have log base 4 of m to the 4th plus log base 4 of n to the 3rd minus log base 4 of p. There's no number to move up to the power there other than 1. Okay, now what?
It'd be like log base 4 m plus n over p. Right?
Not exactly.
M to the, you put
M
log
to the
base
fourth.
parenthesis, M to the fourth, N to the third.
It'd be like log, right? Log base 4.
They're getting multiplied.
Wow.
They're getting multiplied, which part of the problem is, Raja, you said they were being added.
Oh, shoot.
Okay, so 2 logs being added can be rewritten as 1 log where the insides are multiplied. Okay, so I don't know if you realized what you said at the beginning, but it's log base 4 of m to the 4th, n to the 3rd. They're timesing.
And that's over p.
And then when I do my next step, yes, I'm going to say minus log base 4 of p. Everyone's going to jump at different rates, right? I'm probably going too slow, but that's all right. 2 logs being subtracted now. Log base 4 of
M to the 4th, n to the 3rd over p.
n to the 4th, n to the 3rd over p. Now, as I said, Savas was not requiring me to do parentheses last night. So don't feel like you have to put parentheses in Savas. I think they make it a little bit better proper form. But by all means, you get enough typing in Savas that I wouldn't type the parentheses. That's my thought there.
We should work on the next one by ourselves.
Okay, guys. B. Where are we starting? I'm going to keep us moving so I don't run out of time as a class.
Bring
That's
the
my...
threes to the, or like the numbers in the front, bring it to the exponent.
Okay, so the 3
Bring it to
becomes a power on the 2, and the 2
because of power on the 5.
becomes a power on the 5. So when I rewrite this, I have natural log of 2 to the 3rd minus natural log of 5 squared. What do you know?
Oh, shoot.
Okay. Subtracting can become
Multiplying. Dividing
dividing within.
the numbers.
So natural log of
2 to the 3rd times 5 to the 2nd.
he means divided by.
Oh, yeah.
Natural log of 2 to the third over 5 to the second.
And that seems.
Go one more step.
What? Oh. Not gonna go one step.
8 over 25.
2 to the third is 8. 5 squared is 25.
What? Why do we gotta do all that? Why do we
It's
gotta
not
do
that bad. You'll be fine.
25? Oh, gosh.
Okay, it's just moving your powers and actually multiplying them out then. Okay, you ready for C?
Yes.
Again, first step is to
Bring the things.
move the powers.
Yeah.
Now, so this is going to be log of
10.
10 squared plus log of
3x to the 4th.
3x to the fourth. Now, okay, I want to clean these up before we go another step. What do we know about 10 squared? This is going to be log of 100, okay? That's easy enough. Now, this is the reason I want to clean up before we go. 3x, and then we're raising this to the fourth.
Splits, right?
Now we're trying to condense here.
Is it 81 extra 4?
Yeah. My point is this 4 goes on the x, but it also goes on the 3 that's in the log. So this is going to be log of 81x to the fourth. Now, 2 logs being added can be rewritten as 1 log where the insides are multiplied. So this is log of 100 times 81x to the fourth, which is log of what?
8100. Excellent.
8100 x to the fourth. Okay?
Yep. All right, next.
Okay. D. Numbers out front,
Bring it to the expert.
move to powers. Okay, so we're going to have natural log of 27 to the 1/3 minus natural log of 2y to the third. Folks, I've taught you this semester even. What's a 1/3 power mean?
Cube root.
Right? A 1/2 power means square root. 1/3 power means cube root. So this is really natural log of the cube root of 27. What's the cube root of 27? 3. So this is really natural log of 3. Now, what about natural log of 2y to the third?
8y to the 3rd.
This is going to become natural log of 8y to the third. Okay.
And then you divide.
2 logs being subtracted
Divide.
can be rewritten as 1 log where the insides are divided. So it's going to be 3 divided by
8y to the 3rd.
8y to the third.
The last one. We can do the last one.
We can. It's a quick one. I mean, in all honesty, it looks bad because it's 3, but compared to all these others, this is like one of the easiest. What are you doing first?
Bring the numbers in front. Bring it to the expert.
Moving your powers. So log base 3 of 2 to the 8th plus log base 3 of c to the 5th plus log base 3 of d to the 7th. What do we know about 2 to the 8th?
256.
2 to the 8th is 256. So this is log base 3 of 256. Still plus log base 3 of c to the 5th plus log base 3 of d to the 7th. It may not be 2 logs, it's 3 logs. 3 logs being added. 1 log where the insides are multiplied. So this is going to be what? Log base 3 of,
256 c to the 7th, d to the 7th.
okay, 256, c to the 5th, d to the 7th. Okay, guys, in your class, tomorrow, we will pick up We'll do the back side of the notes. In all honesty, tomorrow's notes won't take us the whole period either. So you should have work time tomorrow. And then if all stays on track, you guys will have some free time on Wednesday while I get my other classes caught up. Okay?